Hello, everyone, and welcome back. My name is Mr. Cobalt, and today I'm going to be going over another set of problems for the ideal gas law. They're a little bit trickier. Here, we're going to have to convert and pay attention to things that we're given. Okay, so let's get into this with problem number one. So, problem number one says calculate the number of moles of gas in a 3.24 liter inflated basketball, I should say basketball. Basketball. Okay, so you have a 3.24 liter a basketball inflated to a total pressure of 24.3 psi at 25 degrees Celsius. Now, I have to say something about this idea of total pressure. This idea of total pressure is really important because when you're pumping up your basketball using a pressure gauge, right? So you have a pump, and when you pump up your basketball and then you have a pressure gauge tied to that, that pressure that's being read on the pressure gauge is different than what the total pressure is. So the relationship between total pressure and gauge pressure is the atmospheric pressure. So whatever the atmospheric pressure is going to be indicated by the pressure gauge. So the relationship between pressure, gauge pressure, and total pressure is going to be that the gauge pressure is equal to the total pressure minus the atmospheric pressure. So if they're giving you gauge pressure in the problem, right? So the gauge reads such and such. Then in order to get total pressure, you're going to need to add whatever the atmospheric pressure is to the gauge pressure, and then use the total pressure in your calculation. You need to use total pressure, or what is also referred to as absolute pressure, in your calculation in the ideal gas law. So if they give you gauge pressure, they need to give you atmospheric pressure, so you could add that to the gauge pressure to get the total pressure or the absolute pressure. Okay. Here they're giving you total pressure, so you don't have to worry about doing that calculation. But you may run into a problem where you do have to make that calculation first. So they give us the total pressure, and the pressure is in psi. So if we're going to use the ideal gas law, we need to convert psi to atmospheres. So, and we need to convert our temperature to Kelvin, and that's about it. So, and they're asking for number of moles. So we're going to convert our temperature to Kelvin. So 25 degrees Celsius plus 273.15 is going to give us 298. So 298.15 Kelvin. And again, since we're adding, we're paying attention to decimal places. So least number of decimal places. So I have 2 and I have 0. So I'm only allowed up to here for my sig figs, but I'm going to keep everything to avoid rounding errors. Now I do the same thing for my PSI. So I have 24.3 PSI for my pressure, and I'm going to be using 1 atmosphere is equal to 14.7 PSI. So I can convert from PSI to atmosphere. So 14.7 PSI on the bottom, 1 atmosphere on top. So PSI cancel out, and then I calculate that. Oops. So I'm going to have 24.3 divided by 14.7 equals, and I get 1.65306. So 1.5306. Let me double check. 1.65306. Okay, and that's going to be atmospheres. And once again, I got to check my sig figs. So since I'm multiplying and dividing, I have to be in the least number of sig figs. So I have 3 and 3. So I'm going to cut it off here. So I'm going to underline the 5 because that's my last one. But I'm going to keep everything else to avoid rounding errors. Okay, so now I have Kelvin, I have atmospheres, they want moles, and they gave me liters. So now I can use the ideal gas law. So I have PV equals nRT. We want to solve for moles, so I can divide both sides by RT. So I get number of moles is equal to PV over RT. And now I just plug everything in. So pressure is in atmospheres, so I have 1.653, okay, 06 atmospheres. I'm going to multiply that by the volume, which is 3.24 liters. And then I'm going to divide by R, which is 0.088206, and that's liter atmospheres over Kelvin mole. And then I'm going to multiply that by the temperature, which is 298.15, 298.15 Kelvin. And so you'll notice that Kelvin cancels out, atmospheres cancel out, liters cancel out, and I have moles left. So my answer is going to be moles. And so I calculate, so I multiply the pressure times the volume, 3.24 divided by 0.08206 divided by 298.15 equals, and I get 0.2189. So the number of moles is equal to 2189. So 2189. What does it say? Moles of gas. It says gas. So moles of the gas, probably just air. And so now I need to figure out the sig figs. So I go back to what I underlined. So for my temperature, the 8 was the last one. For my pressure, the 5 was the last one of significance. And so now my answer should be in the least number of sig figs. So I have 3 here, 3 there, 4 here, 3 there. So my least number is 3. So my answer should be in 3. 1, 2, 3. So my final answer is going to be, I'm going to write it up here so I have room. So 0.219 moles of the gas. So that's going to be my final answer. Okay, so let's do number 2. So here, number 2, determine the pressure in millimeters of mercury of, and then you give me grams of the sample of helium gas in a 648 milliliter container at 32 degrees Celsius. Okay, so again, they're giving me a set of conditions. They want me to find the pressure, so this is ideal gas law. So I need to convert everything to the units that I need. And they want the pressure in millimeters of mercury, so I'm going to have to convert that in the end. So they give me gram sample. I can't use mass, I have to use moles. So I'm going to have to use the molar mass of helium to convert that. So I take 0.133 grams of helium, right, over 1. I'm going to use the molar mass. So I got to look up the molar mass of helium, and that's 4.003. So 4.003 grams of helium on the bottom, and then 1 mole of helium on top. So grams cancel out, and then I calculate that, and I get 0.133 divided by 4.003 equals, and I get 0.033, 0.03322. Okay, and then I check my sig figs. So I have 4 here and I have 3 here. So my least number is here. I'm going to keep the extra 2 for to avoid rounding here. So this is moles of helium. Okay, so I have moles. They give me milliliters. I need liters, so I'm going to have to convert that to liters. So I have 648 milliliters of the gas. So we'll say helium in the container. I'm going to use the relationship. So I have liters is equal to milliliters. I always put the 1 with the prefix, and then the prefix multiplier goes with the base unit. So milli is 10 to the negative 3. So now I'm going to put 1 milliliter on the bottom, so 1 milliliter of the helium gas, and then 10 to the negative 3 liters on top, negative 3 liters of helium, so milliliters cancels out, and then I get 0.648 liters of the helium. So now I have my liters, I have moles, and temperature. They give me 32 degrees Celsius, so I need to convert that to Kelvin. So 32 degrees Celsius plus 273.15, and that's going to give me 305.15 Kelvin. So now I have everything in the units that I need. So we want pressure. So I have PV equals nRT. I'm going to solve for pressure. So divide both sides by the volume. Volume cancels out. And I get P is equal to nRT over V. And now I plug everything in. So pressure is equal to the number of moles, 0.03322 moles, multiplied by R, which is 0.08206 liter atmospheres over mole Kelvin, and then multiplied by the temperature, which is 305.15 Kelvin, and then I'm going to divide that by the volume, which is 0.648 liters. And now I just need to calculate. So moles are going to cancel, liters are going to cancel, Kelvin are going to cancel. I'm left with atmospheres. So let's calculate that really quick. So moles times 0.08206 times 305.15 divided by 0.648 equals, and that's going to give me 1.2839. So that's going to be equal to 1.2839, 1.2839, and that's going to be atmospheres, right? And so here, and then I would look for my sig fig. So I have 4 here, 4 here. I'm only allowed 3 here, and I have 3 here. So I would cut it off at 3, and then that would be atmospheres. And then my last step would be to convert this to millimeters of mercury using the equality 1 atmosphere is to 760 millimeters of mercury. And that's it. I hope this was helpful. Let me know what you think in the comment section. Like the channel, subscribe to the channel, like the video, and I'll see you next time.